Hello and welcome for another episode with your favorite Project Lead the Way instructor, Mr. Spaeth. Today we are going to be talking about the mechanical advantage of pulleys. So pulleys, we can consider a lever using a wheel and groove and a rim just to change the direction and magnitude of a force exerted by a rope or cable. So unlike levers and wheel and axles, in order to find the mechanical advantage of a pulley system, we're not measuring anything. All we're really doing is noticing the makeup or the characteristics of the pulley setup. You'll notice this pulley on the right. We call that a fixed pulley. This pulley, notice we're pulling down with 10 pounds of force and it pulls up a 10-pound weight. So really, we're not getting any mechanical advantage there, but what we do is change the direction of the force. And that can be very, very important, especially when we're dealing with heavy loads and we just want to use maybe an offset load. So maybe this would be an elevator system. We have a really, really heavy load pulling down on a lighter load. The next one we have is a movable pulley. Notice they do draw for our movable pulley as a second class lever. You'll notice the fulcrum here on this side, the resistance in the middle, and our effort going in the opposite direction on the end. You'll notice on this one that our effort is only half of what our load is stating. So if we shove that into our IMA equation, we get an ideal mechanical advantage of 2. However, notice it changes the direction of the force. And another thing it doesn't say in here, and I wish it did, is you're going to have to pull twice as high in order to move this just as much as you want to. So let me give you an example. If I want to move this 10-pound load 5 feet off the air, I need to pull on this string 10 feet worth of string. That's because 5 feet are going to be coming out of this portion, and 5 feet are going to be coming out of this string. So remember our equation for work. It was force multiplied by distance, and no simple machine changes how much work we have to do something like lift a weight. So if we reduce the amount of force it takes, this 10 pounds reduced to 5 pounds in order to lift the weight, we're going to have to move it twice the amount of distance just to make sure that work equation stays equal. So like I said, if we had lifted up 10 feet on our effort force, lift this weight up 5 feet off the ground. So very important to remember, and we'll be measuring that in a later activity. Now, pulley systems can get very, very complicated. This one in particular is mounted on a ceiling, and it has 1, 2, 3, 4 different pulley wheels pulling up a weight of 600 pounds. Looks like they're pulling up a motorcycle. You'll notice that we have 1, 2, 3, 4, 5 different strings, it looks like, but actually it's just a single rope. So it's just wound throughout this whole system. Okay? So we call this system in particular a block and tackle. So it provides us a great mechanical advantage, but we're going to have to pull a lot more rope to get it off the ground than we would normally if we were just lifting it ourselves. So if it's a single rope through all these pulleys, we'll show an example later where they're not all single ropes, and we need to calculate that one differently. But if it's a single rope threaded multiple times around a system of pulleys, then the ideal mechanical advantage is equal to the number of strands opposing the force of the load. So the force of the load is down. Okay, gravity gives that load a force downward toward the center of the earth. We are also pulling on this one down. So if we think about that, should we count that strand? So is it opposing the force of the load? Is it, in this case, is it going up? And we would say no. So we would not count this strand for the number of strands opposing the force of the load. But all these other ones are 1, 2, 3, 4 strands opposing, going upward, the force of the load. Therefore, we have an ideal mechanical advantage of 4. All right, compound machines. Compound machines are machines that use 1 or more pulleys, 1 or more levers. They use a combination of simple machines. Now, what we would like to know about compound machines, because we use them every day, is some sort of mechanical advantage of the total system, not just its individual portions. And to find that is actually fairly simple. So to find the total mechanical advantage, and here we're doing ideal mechanical advantage, we would find the ideal mechanical advantage of the pulley system. Okay, and here we have two strands opposing the force of our load going downward, or our load being downward. So we would have number of strands is 2. And then we have the ideal mechanical advantage of our lever. And here we have just a second class lever where we have a distance to the resistance is 4 feet, and the distance to the effort is 12 feet. Now, all we need to do to find the ideal mechanical advantage of the whole system is just multiply those two together. So 2 multiplied by 12 over 4, or 3, gives us 6. Now here I said something about be careful when we're looking at pulley systems. We can only count the number of strands opposing the force of the load if they're all one piece of rope tying all these pulley systems together. Notice here I have 1 piece of rope, 2, and 3 different pieces of rope. So we need to look at these individually. So our first one, and actually each one after this, is just a simple pulley system that takes an 80-pound force and splits it up between 40 pounds on one side, 40 pounds on the other side. So we have a mechanical advantage of each one of these is 2. So to find the mechanical advantage of everything all together, this whole system, all we need to do is take 2 times 2 times 2, which gives us an ideal mechanical advantage of the whole system of 8. And we can see that because we're only pulling up 10 pounds of force here, lifting up an 80-pound force, this resistance in the opposite direction. Okay, so question here, what is the AMA, the actual mechanical advantage of the pulley system on the right? So notice we are pulling down with a force of 230 pounds, and our resistance is 800 pounds. Now, it's the same equation. So actual mechanical advantage is calculated no differently than any other lever or wheel and axle system that we've had before. So we have resistant force and we have an effort force. Plugging those into our equation, we get 3.48 to 1 as our mechanical advantage. Now, ideally, we said this before, ideally we should have had 1, 2, 3, 4. We should have had an ideal mechanical advantage of 4. Notice this 230 pounds is not in opposition to our load, and so we don't count that strand. So we should have had an ideal mechanical advantage of 4. So we can go ahead and calculate our efficiency. So AMA of 3.48 divided by an ideal mechanical advantage of 4. And we find our efficiency at 87%. We're going to be doing this in the lab, our construction with VEX components here shortly. Okay, common misconception, especially when we're measuring these. You need to measure the force of our effort, making sure that it is perpendicular or parallel to the other line that's on your pulley system. You cannot give your strands of your pulley some sort of angle away from this load, because you're going to measure more force there than really what you would have if they were straight up and down. So you're going to get a less efficient simple machine here than you would if you were measuring these straight up and down. So do not stretch those lines out at all, especially when we're measuring. You need to make sure that you're holding those straight up and down to the force of our load. Okay, angles do matter. Okay, another misconception. Count the effort strand if it pulls up. Sometimes. Notice this configuration. So we have our force of resistance is we're actually pulling something down right now. And notice this load right here is pulling down as well. So what we need to make sure is if this count a strand, if it opposes the load or the load's movable pulley, it might pull up or down. Okay, so we just need to make sure we know where our load is and what strands should be counted. They should be in opposition to the load. And that's it. If you have any other questions, feel free to ask your teacher. But if you like this video and would like to see more, please like, link, share, or subscribe. And I'd love to bring you more videos from Project Lead the Way. Thank you.